The brilliant mind of the week is Jamshīd al Kāshī, one of the most significant mathematicians of the medieval world in 1380. His life and contributions. Ghiyāth al-Dīn Jamshīd Masʿūd al Kāshī was born around 1380 in Kashan, Iran. His name, al-Kāshī, refers to his birthplace. He lived during the Timurid dynasty, a period of significant scientific and cultural development in the Islamic world. He spent most of his early life in Kashan, where he worked during difficult conditions under a city siege. The Timurid period, particularly around 1380, was a time of significant cultural and intellectual development. While they didn't have modern technologies like electricity or the internet, they developed sophisticated education, scholarship, and cultural transmission systems. The emphasis on learning and intellectual pursuit created an environment where scholars like al-Kāshī could flourish. Combining religious education with sciences, mathematics, and literature created a rich intellectual atmosphere. While different from modern universities, the madrasa system provided structured higher education and produced many significant scholars and works that influenced later generations. This period demonstrated how a society could achieve high intellectual and cultural development levels, even without modern technology, through well-organized educational institutions, dedicated scholars, and systematic methods of preserving and transmitting knowledge. In 1420, Kāshī received an invitation from Ulugh Beg, grandson of Timur, or Tamerlane, to join his famous observatory and scientific academy in Samarkand. This proved to be a turning point in his life, as he became the leading astronomer and mathematician at what was then the world's premier scientific institution. Al-Kāshī died in 1429 in Samarkand, at the height of his career. Here are some of his mathematical contributions. 1. Computational mathematics. He developed extremely accurate methods for calculating trigonometric tables, computed pi to an unprecedented 16 decimal places, and invented ingenious computational algorithms for calculating nth roots. 2. Decimal fractions. One of his most important contributions was the systematic development of decimal fractions. He wrote detailed explanations of decimal arithmetic, which predated European works on the subject by about 150 years. 3. Astronomy. He developed new mathematical methods for astronomical calculations and created more accurate astronomical tables than were previously available. Kāshī's major works. 1. Miftah al-Hisab, or The Key to Arithmetic. This was his most influential work, a comprehensive treatise on mathematics. It includes sections on arithmetic, algebra, mensuration, and trigonometry, and still influences mathematical education today. 2. Risala al-Muhitiyya, or Treatise on the Circumference. This work detailed his computation of pi and demonstrated his exceptional computational abilities. 3. Zg Kakani, or the Kakani Astronomical Tables. This was a comprehensive astronomical handbook that included extremely accurate trigonometric tables. 4. Risala dar Shari al-Rast, or Treatise on the Explanation of Observational Instruments. This work described astronomical instruments and their use. Lasting influence. His methods for calculating sign values influenced mathematical development for centuries. His decimal arithmetic system laid the groundwork for modern decimal calculations. Miftah al-Hisab remained a standard mathematics textbook in the Middle East for centuries. His clear explanations of mathematical concepts continue to influence mathematical pedagogy. His astronomical calculations and tables were used well into the modern era. The methods he developed for astronomical calculations influenced later astronomers. His work on decimal fractions was revolutionary and predated similar European developments. His computational methods influenced the development of numerical analysis. Since al-Kāshī lived in the medieval period and some sources about his life are limited, I should mention that while his significant mathematical contributions are well documented, some details about his personal life might be subjects of historical interpretation. However, his mathematical works and their influence are thoroughly verified through his surviving manuscripts and their impact on later mathematical developments. His story also illustrates the significant role of patronage in medieval Islamic science, as his most productive period came under the patronage of Ulugh Beg in Samarkand. The collaboration between al-Kāshī and other scholars at the Samarkand Observatory led to some of the medieval period's most accurate astronomical observations and calculations. More of his work. Al-Kāshī's method for calculating pi was one of his most impressive achievements. He used an ingenious polygonal approximation method. His process involved starting with a regular polygon of 3 × 2 elevated to 28 sides, using sophisticated iteration techniques and computing pi to 16 decimal places. His result, pi equals 3.14159265358979323. He introduced systematic decimal fractions through a clear positional notation system, with place values marked by specific Arabic letters. His most innovative computational method was for calculating nth roots. Here's his approach. He used what we now call the Newton-Raphson method. His iteration process involved making an initial guess, applying the formula iteratively, and continuing until the desired accuracy is reached. His method for computing sign values was particularly sophisticated. It involved starting with known values, using double and triple angle formulas, and applying systematic error reduction. For calculating volumes of complex shapes, he developed the method of rings. This involved dividing the object into circular rings, calculating the volume of each ring, and summing the volumes. His computational methods often followed this pattern: define an initial value, set a precision goal, and choose the iteration method. While precision was not met, he would apply a transformation, check the error, and update the value. He was meticulous about error control, maintaining extra digits during calculations, using bounds to estimate errors, and applying systematic error reduction techniques. He applied these methods to astronomical calculations, such as solar position, lunar phases, and planetary motions, as well as architectural computations like dome volumes, arch measurements, and structural calculations. His system for managing decimal places was revolutionary. The integer part was called mrtba, martaba. The decimal part was ksr, kasa, and place values were shri, ashari. His computational methods are relevant to modern numerical analysis. They include iterative approximation techniques, error estimation methods, and convergence acceleration strategies. While these methods were incredibly sophisticated for their time, they were particularly remarkable because they anticipated many concepts in modern numerical analysis. His work on iterative methods mainly shows striking similarities to later developments in computational mathematics. His methods were not just theoretical, but also had practical applications in astronomy, architecture, and commerce. They remained influential in the Islamic world for centuries and, through various translations and adaptations, influenced European mathematics as well. This systematic approach to computation, especially his work on decimal fractions and iterative methods, laid important groundwork for later developments in numerical analysis and computational mathematics. His methods for calculating pi and trigonometric functions remained among the most accurate until the advent of electronic computers. If you like the video, consider subscribing to the channel. Thank you for watching.